Okay, so now we're going to learn how to solve rational inequalities. Now we solve rational inequalities in the same way we did with polynomial inequalities, which you've already done. So let's recall, let's solve the inequality p of x is greater than 0. This is just a regular polynomial, so I'm going to draw a picture like so. And this is A, this is B, this is C. Okay. So where is the function, this polynomial p of x, greater than 0? It's greater than 0 when it's above the x-axis. So it's above the x-axis from negative infinity all the way to a. Now this is a strict inequality, so I don't include a. Now it's below the x-axis, and then it's above the x-axis from b to c, and then it drops below the x-axis. So that's the solution. Okay, so let's remind ourselves how to do it algebraically. So the first thing we want to do is we want to bring everything over. And then we're going to factor. So let's make sure that's right. So negative 4 times 3 is negative 12 times x is negative 12x. That works. X times x is x cubed. That works. Negative 4 times x is negative 4x plus 3x, which will give me negative x times x is negative x squared. Good. So where are the interesting places? Well, the interesting places on here are at 4, are at negative 3, and at 0. Now, if we know how this function behaves, we know that the function is 0 at 0 at negative 3, 0 at 0, and 0 at 4. Now, because it's a degree 3 polynomial with leading coefficient positive, on the very left-hand side, it's negative. And then this 0 has a multiplicity of 1, so it crosses through and becomes positive. And then this 0 has a multiplicity of 1, so it crosses through and becomes negative. And this 0 has a multiplicity of 1, so it crosses through and becomes positive. So if you don't know how to do that with the multiplicities and the end behavior, then you have to plug in test points. Okay, now I want to know where the function's less than or equal to 0. So it's less than or equal to 0 from negative infinity all the way up to negative 3. And then from 0 to 4. Okay, so now that we've reviewed because we've already done this, now we're going to repeat the process with rational functions. So solve the inequality Rx is less than or equal to 0 where R of x equals this. So we just graph the function. Now we'll notice, by the way, that let's just do a quick review here, that if I plug in negative 2, that'll give me 0 on the bottom, but not on the top. So there's a vertical asymptote at x equals negative 2. The degree of the top is 3, the degree of the bottom, so the degree of the top is 1, and the degree of the bottom is 1. So leading coefficient divided by leading coefficient is y equals 3 halves. So this right here is the horizontal asymptote, which I'll call HA, and the vertical asymptote, which I'll call VA. It didn't ask for that. So what we want to do is we want to know where the function's less than or equal to 0. Well, it's less than or equal to 0 where the graph's below the x-axis. So it's below the x-axis from negative 2 to negative 1. Now, less than or equal to 0. So it's actually equal to 0 at negative 1. There we go. See how easy that is? All right. So now we're going to do this. So we've got x minus 1 over x plus 2. And we know that the important points are 1 and negative 2. Now at negative 2, the function is undefined. So I'm going to write a u for undefined there. And at 1, the function's 0. Now it's up to you what you want to do. But I'm going to use, you can use test points or you can just use other stuff, but I'm going to use test points. So I'm going to plug in negative 4. So if I plug negative 4 into here, I'm going to get a negative on the top and a negative on the bottom, which gives me positive. So everything's going to be positive over here. Now I'm going to plug in 0. If I plug in 0, I'm going to get negative on the top, and I'm going to get negative on the top and positive on the bottom. So I'm going to get negative. Now let's have a look at the multiplicities here. This x plus 2 only occurs one time, so it's going to change. Yep. All right, now we're going to do pick a point here. We'll try 4. So plugging in 4 into the top makes it positive, and 4 into the bottom makes it positive, so it's positive. So I want to know where it's greater than or equal to 0. So it's greater than or equal to 0 from negative infinity all the way up to negative 2. Now I can't include negative 2 because the function's undefined there. And then union 1 to infinity. Now 1 I can include because it is defined there. It's 0 at 1. And that is how you do section 4.4.